All right. Hello, folks. Let's go ahead and look at this KB example from one of the problem sets you're going to do this week. And let's go to the first one. Let's see, my pen is... Come on, pen. There we go. And let me just erase this. So our computer is acting a little bit funky today. There we go. And get to the pen. So for the following compounds, we're going to get a list of compounds. We need the base dissociation reaction. So on this problem set, that's the first thing we need. We need this reaction, right out, complete balanced reaction. Then I want the KB expression. Then I want chemical, each concentration of each chemical in solution, and finally calculate the pH. So we've got about 4 steps we need to do on this. So let's look at the base dissociation reaction. So we got this. Now on this, because this is a handful to write, if you want to just write B, for this is B, plus H2O, goes to BH plus OH minus. That's an acceptable way to write this compound. Now, if you want to do it the long way around, we'll come up here and just go C4H5N plus H2O. And that will yield C4H5, and I'm going to write NH positive because the nitrogen is attached to, hydrogen is going to be attached to that nitrogen, plus OH negative. Either way will be fine by me. And this is the balance equation. Now the KB expression I'm going to write here, and let's go to the next one. KB is going to be the products over the reactants. So the product is BH. I'm just using my abbreviations, and I'll do the other one in a minute. OH minus. Excuse me. Over BH. Sorry, B. So if we look at that, that's going to be, let me make sure I got the reaction right, C4H5N. C4H5NH positive, OH negative, over C4H5N. All right, so that's our KB expression. This is what I'm looking for, guys, on the test. Don't make it too complicated. Write the base dissociation reaction. 1. Write the KB expression. 2. Then determine the concentration of each. So this is where your ICE table comes in. So we got C4H5N goes to C4H5NH plus OH minus. Now the initial concentration is important, so we've got 1.25. 1.25 is what we have initially, and 0 of this, and 0 of that. Now, we're going to subtract x from this. That means we'll have x of that and x of that. And then, at equilibrium, the E, that's 1.25 minus x is equal to x times x. Now, this is going to be important, because now we're going to substitute this into the KB. So, BH, it's going to be this, that's x. OH minus is going to be x. And C4H5N is going to be B. So if we go to the next one, KB, which is going to be this value, 2.02 times 10 to the third. Ten to the minus 3 is equal. And we're going to have x and x times 1.25 minus x. And that's going to give us x squared over 1.25 minus x. Now we're going to end up with a quadratic equation. So let's go ahead and multiply both sides by 1.25 minus x. Minus x equals x squared. And so 2.02 times 1.25. That's going to give me, so I multiply these two. So I distribute through 2.525. I'm going to keep all my digits at this point. Times 10 to the minus 3 minus 2.02 times 10 to the minus 3x is equal to x squared. So x squared plus, let's move everything over to one side, so my quadratic formula I have to solve is x squared plus 2.02 times 10 to the minus 3 minus 2.525 times 10 to the minus 3. And this is supposed to be an x. I forgot my x. There we go. Excuse me. I need a drink. Coffee, folks. Nothing else. So x is equal to minus b plus or minus the square root b squared minus 4ac over 2a, where a is going to equal 1, b is going to equal 2.02 times 10 to the minus 3, and c is equal to this 2.5 negative 2.525 times 10 to the minus 3. So x is going to equal some number, and let me go to my next slide and say x is equal to, see, coming up and back to b minus 2.02 times 10 to the minus 3 plus or minus, and it's going to be plus, not minus, so I'm just not going to worry about that because I don't need a negative number. And that's 2.02 times 10 to the minus 3 squared minus 4. A is 1 and c is a negative, so that becomes positive, and it's 2.525 times 10 to the minus 3. And all that is over 2a, now, and which is 1. So what I'm going to do is start on the right-hand side. So take my 2.525 raised to the minus 3. I'm going to multiply it by 4. And then I'm going to add to that 2.02 times 10 to the minus 3 squared. And the number I get is going to, inside the square root, is 0.010104 ... That's more digits after that, but I'm going to take the square root of that number, and I'm going to have minus 2.02 times 10 to the minus 3 plus, I want a positive number, 0.1005 and all that's divided by 2. So subtract 2.02 raised to the minus 3, then divide by 2, and x is going to give me 0.04925, and that's my x. So going back, this is going to be the concentration of C2 of C4, H5, and H positive. And that's also going to equal OH negative. And that's going to be 0.04925. And the concentration on my initial base, C4H5N, is going to equal 1.25 minus that, So 1.200. So this is the concentration on each species in solution. This is going to be 1.2, and these are going to be 0.04925. Now, so this is what I want to see, guys. And now I've done this. Determine the concentration of each chemical in solution. Remember, this is giving me OH, not H+. I need to find H+ now. So there's several ways to do that. So pH plus POH is equal to 14. And then if I know the concentration of OH minus, that's going to be 0.049. All right, so let's take the negative log of the concentration of OH minus and that's going to give me the POH. It's going to be 1.31. And so pH is equal to 14 minus 1.31, which should be 612.69. And there's my last answer. So going back through, I want to write the base dissociation constant reaction, which is this or up here. Either one is fine. Then I want the Kb expression. That's this. Each of those is going to be 5 points. Then I want to see this to figure out the concentration of my solutes, which is right here. This is 10 points. And this is going to be 5. So this is how you calculate the pH of a weak base solution. A little bit lengthy, but you guys can do it. All right.